So here we're going to go ahead and talk about the other type of asymptote, and that is a horizontal asymptote. Now, horizontal asymptotes describe the end behavior, so as x approaches either positive or negative infinity. Okay, and so they're not a domain restriction, they're just kind of where the graph ends up kind of leaning toward as x gets really big or really negative. So let's go ahead and look at those limits. I'm only going to look at the positive direction because it really doesn't matter in the end. So you'll notice that I only took this first part here, and in previous videos when we talked about the polynomial functions, we decided that as x gets really big, none of this other stuff really ends up being big enough to compete with our big powers on the top and bottom here. So as x gets really big, it's just going to approach the biggest power on the top and the biggest power on the bottom, those terms with the biggest powers. And so I'm going to do the same for the rest of them, and then we'll talk about them. Here we have our three limits, and all I'm going to do is reduce them. And what we're going to find is that will actually give us our horizontal asymptote. So in the first one here, for example, I can divide one of these x's on the top with one of the x's on the bottom, leaving x squared or 2x's on the bottom. And what I wind up with is just 3 over 2x squared. Now I'll do that with the rest of them, and then we'll kind of talk about where they're going to go. All right, now as x approaches infinity, that means that this denominator is going to get really huge. And I've kind of illustrated this in other problems, but if we just kind of imagined an example of 3 over, let's say, when x is, 1,000,000, then we're going to, or not even 1,000,000, let's do like 100, we're going to end up with 2 with 1, 2, 3, 4 zeros under it. Well, you know what? That's getting really, really close to 0. What we find is, in this case, since the numerator is going to remain the same and the denominator is going to get bigger and bigger, we're just going to approach the y-axis, or y equals 0, and have an asymptote right here on the, x-axis. So that's where we get a denominator on the, we get an asymptote on the x-axis. So let's go ahead and look at what happens in this second example here. Well, in the second example, I don't even have to look at a limit. I know that y is just going to approach 3 over 2. And so if I make this like 1 unit up here, then I know that I'm going to have a horizontal asymptote here at 1 1/2, or 3 over 2. This is moving along quite nice. So in this last case, what we wind up with is this numerator is just going to get bigger and bigger and bigger. There is no real bound. It's just going to approach positive infinity. Well, if that's the case, that actually means that there is no horizontal asymptote. So we have 3 basic cases. Now you can kind of try to come up with a rule on your own, but you'll notice all I did was simplify, okay, those lead terms, and then look at what that line would even be. Now, there is actually one other example of a kind of horizontal type asymptote, and that is a slant asymptote. Now, it has a lot in common with this case where we have no horizontal asymptote. So in this one, you'll notice the degree of the numerator was 3. The degree of the denominator was 1. So in other words, the degree of the numerator was greater than the degree of the denominator. Well, if you'll notice in this other example here, s of x, we have that same relationship. The numerator is exactly 1 degree bigger than the denominator. So if you imagine what happens here if we look at the limit, we end up with 3 over 2 times x. Well, that is just the equation of a line with a slope of 3 over 2. I want to point out this is not the equation of our asymptote. I will go over how to find the equation of a slant asymptote in another video, but that is a very common mistake people make. Just keep in mind that if it ends up looking like this, that tells you that there is an asymptote, but you haven't found it yet.